Arc welding. Shielded metal arc welding is also referred to as stick welding or manual metal arc welding, in short, MMAW, in which an arc is struck between the flux-coated consumable electrode and the base metal to start the welding process. It is the most common type of welding process seen in any job shop industry. Working principle. In this process, the heat required to melt the consumable electrode and form a bond with the base metal is produced by an electric arc struck between the electrode and the workpiece. The shielding for the weld pool is provided by the flux, some of which is deposited on the layer of the weld in the form of slag, which is removed upon cooling. The choice of electrode depends upon the base metal composition. Equipment or components of shielded metal arc welding. Power supply. Transformer. Most commonly, welding transformer, a DC rectifier, or a DC generator is used. Electrode holder. Electrode. Ground clamps. Working. First, the power adjustments are made on the transformer. The welding can be carried out by either using direct current electrode positive, DCEP, or direct current electrode negative, DCEN, connection. DCEN. In DCEN, the electrode is connected to the negative terminal and the workpiece is connected to the positive terminal. The electrons thus travel from the negative terminal to the positive terminal. That is, from the electrode to the workpiece. Since there is a sufficient potential difference between the electrode and the workpiece, therefore the electrons from the electrode accelerate and strike the workpiece surface at a very high velocity. Upon striking, the kinetic energy of the electrons is converted into heat or thermal energy, thus an immense amount of heat is generated at the workpiece surface. About 66% of the arc heat is generated on the surface of the workpiece, and the rest of the heat is generated at the electrode surface. This melts the base metal quickly, thus resulting in deeper penetration. However, the deposition rate of the filler metal reduces due to less heat generation at the electrode surface